All right, let's get right into it. You know the most powerful AI models on the planet, right? Google's Gemini, OpenAI's GPT, Anthropic's Claude, they've been absolutely crushing every test we throw at them. But then, this new kind of mysterious benchmark shows up, and these same genius AIs, well, they started failing. And not just failing, but failing spectacularly.
This is what they're scoring. Seriously, less than 1%. On a test that's supposed to measure true general intelligence, our very best AIs is getting pretty much nothing. So what on earth is going on?
And that's really the core of the mystery here, because while these AIs are just completely, utterly stumped, humans can solve these problems basically every single time, usually in just a few minutes. It's this huge, unexpected gulf between us and them. And the answer to this paradox? Well, it's probably not what you're thinking.
See, the test isn't some crazy hard math problem or a multiple-choice quiz. It's a game. A simple, abstract, turn-based game. And the reason our smartest AIs are failing so badly comes down to two big things: how you play this game, and maybe even more importantly, how it's scored.
So this new challenge is called the ARC-AGI-3 benchmark. It was created because researchers were getting worried about something called benchmark saturation. This idea that AIs weren't actually learning how to reason, they were just getting really good at memorizing the answers to all the old tests. So the folks behind this decided to build something totally different.
And here is the absolute kicker. There are no instructions. None. The AI just gets dropped into one of these little grid worlds and has to figure everything out. What are the rules? What am I even supposed to be doing here? It has to learn by just trying stuff, by exploring and seeing what happens. And that is a huge shift, from being told a problem to solve to having to discover what the problem even is in the first place.
And this comparison just lays it all out perfectly. On the left, you've got the old way, static tasks. Here are a few examples, now figure out the one rule. The goal was always spelled out for you. But now, on the right, you've got this new game. It's an interactive world where you have to discover the goals. The AI literally has to build its own mental model of how this little universe works, from the ground up.
You know, what's really fascinating is what this game is built on. It's not testing anything from the internet. It's not about facts or figures. It's testing what psychologists call core knowledge. These super basic, intuitive ideas that we humans just get. You know, things like, that's a solid object, or if I push this thing, it'll probably move. It's a test of pure, fluid intelligence, totally separate from anything you could just memorize.
But look, understanding the game, that's only half the story. The real reason the AIs are scoring less than 1% isn't just that the game is hard. No, it's because of how success is actually measured. The scoring system they came up with is, well, it's absolutely brutal.
Okay, so the benchmark introduces this brand new way of thinking about intelligence, and it's called action efficiency. It's not about if you can eventually solve the puzzle, it's about how many moves it takes you to solve it the very first time you ever see it. It's designed to reward quick, intuitive understanding and to heavily penalize just trying things over and over again until something works. Let me give you a quick example. So let's say for a certain puzzle, the human baseline, which is based on really good players, is 10 moves. Now the AI, it's exploring, trying different things, and it eventually solves it in 40 moves. So it's 4 times slower. You'd think, okay, it gets a score of 25%, right? Nope, not even close.
This is the killer detail. The score is calculated by taking the ratio of human actions to AI actions, and then they square it. So being 4 times slower doesn't get you a quarter of the points. It gets you 0.25 squared, which is just 6.25%. A tiny bit of inefficiency leads to this massive exponential penalty. And get this, if an AI is more than 5 times slower than the human score, its score for that puzzle is just 0, flat out.
So how does this brutal scoring actually play out on the leaderboard? Well, just look at this collapse. You've got models that were scoring in the 80s on the old static tests, and now they're pulling in fractions of a percent. This isn't just a small step back, it's like they've fallen off a cliff. It just goes to show you how much this new benchmark has totally changed the game.
Now, whenever you see scores this low, you know a big debate is going to follow. Is this benchmark a truly fair way to measure intelligence, or is it, like some critics are saying, basically designed to be anti-AI?
And this quote from one observer pretty much sums up that feeling perfectly. The argument from critics is that the scoring system specifically is really flawed, and it doesn't give you the full picture of what these AI models are actually capable of. So here's the heart of their argument. They say the scoring is asymmetric. So if an AI is brilliant and figures out some clever shortcut to solve a puzzle in half the human time, its score is just capped at 100%. No bonus points for being a genius. But if it's even a little bit slower, that insane quadratic penalty kicks in and just destroys its score. It's a system of what they call erased wins and amplified losses.
The second really big criticism is all about how the AI even sees the game in the first place. One critic actually called the input the AI gets symbolic sludge. And honestly, when you see how it works, you kind of get why.
This is what's called the modality handicap. You and I, we play this on a screen. We use our eyes, our visual intuition to spot patterns. The AI, though, it often gets the game state fed to it as just a giant wall of code, a long list of numbers that represent the grid. It makes you wonder, are we really testing its reasoning ability, or are we just testing how well it can decode a really terrible user interface?
And there are a few other complaints too. For instance, that human baseline score isn't an average person, it's an elite performer. The human testers get a little hint that they need to figure out the rules, while the AIs often get nothing at all. And that super strict cutoff at 5 times the human action count, it really penalizes any AI that needs to do a lot of exploring to learn the ropes.
But here's the thing. Despite all the controversy, there is a huge upside to a test that is this hard. It is forcing the entire field of AI research to evolve. It's pushing everyone past the old ways of thinking and driving us towards something genuinely new.
And this really captures the whole shift perfectly. For years, the main path to better AI was just scaling. More data, bigger models, just make everything bigger. This benchmark is basically signaling the end of that. Now, the focus is on building agentic systems. These are AIs that can explore, that can strategize, that can adapt to totally new situations on the fly. It's a fundamental move from just being bigger to actually being smarter.
So how do you even build a smarter, more agentic AI? Well, one of the coolest new ideas is this team of thoughts architecture. Instead of having one giant model try to do everything, you have a whole team. There's a central orchestrator AI that looks at the problem. It then asks its team of specialist AIs, one for spatial logic, one for planning, and so on, hey, who's got the skills for this? And then it activates the best ones to work together on a solution. It's basically AI as a collaborative team, not just a single genius.
And this whole thing leaves us with a really fascinating final thought. This benchmark redefines intelligence. It's not about what you already know, but about how efficiently you can learn something brand new. It kind of forces us to think, if real intelligence isn't a library of facts, but the speed and agility of your mind when you're faced with a complete unknown, well, that's a question worth asking, not just about machines, but about ourselves too.